Dear students, welcome. This is our class number 12 on statics. Today, we shall try to solve these three problems on statics. Today's question number 1, see this. Forces acting at a point are represented by 2AB, 3BC, 2CD like this, where ABCD is a quadrilateral, so that the forces are in equilibrium. The forces are acting at a point O, but they can be represented by this. Let me write the quadrilateral first. Let me draw the quadrilateral first. Any type of quadrilateral you may draw it. Suppose this is A, B, C, D is a quadrilateral. 2AB, a force is represented by 2AB, 3BC, 2CD, also DA, also CA, Not only that, DB, draw DB also. DB. We have to show that the forces are in equilibrium. We have 2AB plus 3BC plus 2CD plus DA plus CA plus DB, these factors. This is equal to, the forces represented by this can be written as AB factor, AB plus BC plus CD plus DA. You may write like this, plus AB plus BC plus CD plus DA. Out of 2AB, 1 AB has been written. Out of 3 BC, 1 BC has been written. We have written 1 BC. Now, plus another AB, right? Another AB and BC, AB plus BC and the CA, right? This time CA plus all the 2 AB have been written. Out of 3 BC, 1 BC, 2 BC has been written. 1 BC is left. And 2 CD, 1 CD, 1 CD, 1 BC. Therefore, you may write BC plus CD plus, it has already been, and DB. You may write like this. Now see the diagram. AB plus BC plus CD plus DA, it is equal to 0, because if some forces acting at a point be represented by the sides of a closed polygon taken in order, then the forces are in equilibrium. It is a quadrilateral AB, BC, CD, DA. By polygon of forces, this is equal to 0. Also, AB plus BC plus CA, AB plus BC plus CA, by triangle of forces, if 3 forces acting at a point be represented in magnitude and direction by the sides of a triangle taken in order, then the forces are in equilibrium. Therefore, by the triangle of forces, this is equal to 0. Also, BC plus CD plus DA, this is also equal to 0 by the triangle of forces. This is equal to 0 by polygon of forces. This is equal to 0 by triangle of forces. This is equal to 0 by triangle of forces. Equal to 0. This is equal to 0 plus 0 plus 0. Equal to 0. Therefore, the forces are in equilibrium. You may write like this. Therefore, let me remove this one. We have to show that the forces are in equilibrium. We have to show that the forces are in equilibrium. Because AB plus BC plus CD plus DE, the forces are in equilibrium by the polygon of forces, by polygon of forces. By polygon of forces, this is equal to the forces represented by this will be in equilibrium. What is the polygon of forces? If a number of forces acting at a point be represented by the magnitude and direction by the sides of a polygon taken in order, then the forces are in equilibrium. By the polygon of forces, this will be equal to 0. AB plus BC, AB plus BC plus CE will be in equilibrium by triangle of forces. By triangle of forces, not only there, BC plus CD plus DB equal to again 0, means the forces will be in equilibrium by the triangle of forces, by triangle of forces. Therefore, the forces acting at a point represented by this will be in equilibrium. Therefore, you may write like this. You may write, finally you may write, therefore the forces acting at a point represented by twice AB, 3 BC, 2 CD, DA, CA, and DB of the quadrilateral ABCD. Of the quadrilateral ABCD. Therefore, the forces acting at a point represented by this of the quadrilateral ABCD will be in equilibrium. Will be in equilibrium. Will be in equilibrium. Therefore, question number 13. Today's question number 1 has been solved. Perhaps you have understood this. We have solved the question number 13. See the question number 14. What is it? A uniform plane lamina in the form of a rhombus. A uniform plane lamina in the form of a rhombus, one of whose angle is 120 degree, is supported by two forces P and Q. P is greater than Q. Applied at the center along the diagonals such that one side is horizontal, one side is horizontal. Then we have to show that P square equal to 3Q square. We have to show that P square equal to 3Q square. Now, let me draw a diagram here. ABCD is a rhombus. In a rhombus, draw the rhombus. Opposite sides are parallel. A, B, C, D is a rhombus such that one side is horizontal, CD is horizontal. Suppose CD is horizontal. Now, draw the diagonals. Now we draw the diagonal. AC and BD of the rhombus, they meet at the point O. Means O is the center of the rhombus, which is the center of the rhombus. Now, two forces P and Q applied at the center. Applied at the center. Along the diagonals. Along the diagonals. P is acting along OD and Q is acting along OC. Along OC. Now, one angle is 120 degrees. Suppose this angle is 120 degrees. 120 degrees. We took the rhombus. This is the weight of the rhombus. W. Weight of the rhombus is this. This O. It will be vertical. The weight of the rhombus will be acting vertically downwards. Therefore, this is a vertical line. Suppose it cuts the side CD of the rhombus at the point E. At the point E. Now, let me write this. Let ABCD let ABCD be the rhombus with the side CD as horizontal. First write like this. Let ABCD be the rhombus. Let ABCD be the rhombus with side CD horizontal. With side CD horizontal. Let O be the center of the rhombus. O be the center of the rhombus. Let O be the center of the rhombus. We draw the diagonals. AC and BD are diagonals. Are diagonals of the rhombus. Of the rhombus ABCD. AC and BD are diagonals of the rhombus ABCD. The forces P and Q, the forces P and Q are acting at the center O. Are acting at the center O. Center O along the diagonals along OD and OC respectively, right? Respectively. Along OC and OD respectively. W is the weight of the. Let W be the weight of the rhombus. Which will be acting vertically downwards through the center of the rhombus. Which acts vertically downwards. Vertically downwards through the center of the rhombus. Through the center of the rhombus. Now you see the three forces P, Q and W acting at O are in equilibrium. Acting at O is supported by two forces This means that three forces are in equilibrium. Therefore, by Rabi's theorem, three forces are in equilibrium. You see, the three forces are in equilibrium. Two forces are in equilibrium. When two forces are in equilibrium, we say that the two forces P and Q are in equilibrium, or R and S are in equilibrium. One force is acting along a straight line. Other force S is acting along the same straight line in opposite direction. In opposite direction. Now, you see, the three forces P, Q, and W are in equilibrium. This means that the resultant of P and Q must act vertically upwards. Must act vertically upwards, and it will be equal to W, right? Resultant of P and Q must act vertically upward, or in opposite direction. W is acting in vertically in this direction, vertically downwards. Therefore, the resultant of P and Q must be acting vertically upwards. Must be acting vertically upwards. This means that must be acting vertically upwards. This means that suppose this angle will be equal to 90 degree. CD is horizontal, OE is vertical. Therefore, this will be equal to 90 degree. Center of the rhombus. Since the forces P, Q, and W acting at the O are in equilibrium, therefore, the resultant of P and Q must be equal and opposite to W. Must be equal and opposite to W. This means that therefore the resultant of P and Q must act vertically upwards. Through O means through the center, through. Vertically upwards through O. The resultant of P and Q. This is the resultant of P and Q. Suppose it meets suppose this vertical line meets the horizontal line CD of the rhombus at the point O. Suppose this vertical line meets the horizontal line CD at the point E. Now, ADC. This angle equal to 120 degree. ADC is equal to 120 degree. Therefore, CDO, this angle equal to half into ADC. This is equal to half into 120 degree equal to 60 degree. It will be equal to 60 degree. Means this angle will be equal to 60 degree. This angle is 60 degree. It is 90 degree. This means that what will be this angle? Angle will be equal to 30 degree. It will be equal to 30 degree. Right? It is 30 degree. Again, it is a rhombus. ABCD is a rhombus. AC and BD are diagonals. This means that COD, This angle will be equal to 90 degree. Now ABCD is a rhombus. CD is a rhombus. And AC and CD are diagonals. AC and BD are diagonals. Diagonals. Which meet at O. Therefore, COD, this angle will be equal to 90 degree. COD, this angle will be equal to 90 degree. Now, this is 30 degree. Therefore, what will be this angle? This angle will be equal to 60 degree. Now, you see. These are vertical lines. This angle is equal to this angle. Vertically opposite angle. Now this is 30 degree. These two lines 30 degree. Therefore this angle, what will be this angle? This angle will be equal to 30 degree. And this angle will be equal to again 60 degree. This angle is 60 degree. Vertically opposite angle. P divided by COW, it will be like this. Now, since the forces P, Q and W acting at O are in equilibrium, therefore by Ramen's theorem we get Ramen's theorem we get P divided by sine of COW. Therefore by Ramen's theorem we get, I am writing here, P divided by sine of COW equal to Q divided by sine of DOW. This is equal to W divided by sine of COD. What is Ramen's theorem? If three forces acting at a point are in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two. Therefore, magnitude of the force P should be equal to the sine of the angle between Q and W. This angle will be equal to this angle. This means that P divided by sine. What is COW? It will be equal to 180 degree minus 60 degree. This angle is equal to 180 degree minus 60 degree. This is equal to Q divided by sine. DOW means 180 degree minus 30 degree. This is equal to W divided by sine. It is 90 degree. Sine, this is 90 degree. Therefore, this means that P divided by sine 60 degree equal to Q by sine 30 degree. This is equal to W by 1. This means P divided by root 3 by 2 equal to Q divided by 1 by 2 equal to W. This is equal to W. This means 2 will be cancelled. P equal to root 3Q means P square equal to thrice Q square. P square equal to thrice Q square proved. P is greater than Q, P square is equal to thrice Q square. We have proved this problem also. Perhaps you have understood. This is a very easy problem and simple application of Ramen's theorem. We have proved that question number 14. Today's question number 2. Now, finally, I am going to solve the question number 15. What is the question number 15? Three forces act in a given direction at a point O and are in equilibrium. If a circle is drawn through O to cut the lines of action of forces in ABC respectively, prove that the forces are proportional to the sides of the triangle ABC. Triangle ABC. Let me remove this first. Three forces act in a given direction at the point O and are in equilibrium. A circle is drawn through O to meet the lines of action of the forces in ABC respectively. Now, first we should write the directions of forces through O, and through O we should draw a circle, but for your convenience, first draw the circle. First draw the circle. This is the circle. Suppose this is circle. This circle. Through the point O, three forces. This is a point O. A force is acting along this direction. Suppose this is P. It is O. And it is a force Q. It is acting in this direction, and this is the force R, acting at the point O. Acting at the point O. This the three forces. The three forces meet. The three forces are acting at the point O. Through O, if we draw a circle, then the circle will cut the lines of action of the forces at the point A, B, and C respectively. A, B, and C respectively. According to the question. Now, let me join BC, CA, and AB. BC, CA, and AB. BC, CA, and AB. According to the question, here you may write the three forces PQR are acting at the point O. Acting at the point O. If a circle through O is drawn, then the lines of action, then the circle cuts the lines of action. Then the circle cuts the lines of action of the forces P, Q, and R at points A, B, and C respectively. A, B, and C respectively. Therefore, we can say that the forces PQ are acting along the line OA, OB, and CO. Therefore, we can say that the forces P and PQR are acting at O along OA, OB and CO respectively. Next, let me join BC, CA and AB. BC now, BC, CA and AB are joined. BC, CA, AB are joined. Now you see. It is given that the forces are in equilibrium. You can apply Lami's theory. Therefore, you can apply Lami's theory. Since the forces PQR acting at O are in equilibrium. Therefore, by Lami's theory we get the magnitude of each force is proportional to the sine of the angle between the other. Therefore, by Lami's theorem, we get the magnitude of each force P divided by it will be QOR sine QOR equal to Q divided by sine POR or ROP indirect. This is equal to R divided by sine POQ. By Lami's theorem we can write this. Now QOR. This means that P divided by sine. What is QOR? QOR is this. This is equal to 180 degree minus BOC sine 180 degree minus BOC. 180 degree minus BOC. This is equal to Q divided by sine POQ ROP this angle. 180 degree minus this angle. What is this angle? COA. 180 degree minus COA. This is equal to R divided by sine. R divided by sine. POQ means sine POQ means AOB. You may write sine AOB. This is nothing but sine AOB. Up to this step, I think this is. There should not be any confusion up to this step. This means that P divided by sine 180 degree minus theta. This is equal to sine BOC equal to Q divided by sine COA equal to R divided by sine AOB. Suppose like that. This means that P divided by, you see, BOC. Consider this chord BC. And from BC, you see, this angle will be equal to BAC, sine BAC. Is it clear? Consider this chord. From this chord, this angle BOC will be equal to BAC from geometry of class 9 or class 10. Q divided by sine COA. COA. Again, same formula. Consider this CA. This angle COA should be equal to this angle ABC. This angle should be equal to this. This angle should be equal to this. Also, from this angle is equal to this angle. I have written cross sign. These two angles are equal. This angle should be equal to this angle. From class 10 geometry, also consider this angle should be equal to this angle. The right sign, we have written these two equal angles as right sign, and these two angles are also equal. We have written cross sign. Sin COA, sin COA, COA. This angle should be equal to ABC. ABC should, this is equal to R divided by sin AOB. You see, OACB is a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles are supplementary. This means the sum of the opposite angles should be equal to 180 degree. Sum of this and this should be equal to 180 degree. Sin AOB should be equal to sin 180 degree minus ACB. ACB. We have applied the logic. In a cyclic quadrilateral, the sum of the opposite angles are supplementary. Means the sum or the opposite angles are supplementary. This means that the sum of the opposite angles in a cyclic quadrilateral is 180 degree. Sum of the opposite angles of a cyclic quadrilateral is 180 degree. In a cyclic quadrilateral, the opposite angles are supplementary. Since in a cyclic quadrilateral, the opposite angles are supplementary. Means sum of the opposite angles in a cyclic quadrilateral is equal to 180 degree. This means P divided by sine in a triangle ABC. You see, in a triangle ABC, the angle ABC is written as angle B. Angle BCA is equal to angle C. Angle CAB or BAC is equal to angle A. Now, angle BAC, I can write here angle A. Q divided by sine ABC means sine B, and R divided by here sine 180 degree minus theta means sine theta, ACB. Here also, this means P divided by sine A equal to Q divided by sine B equal to R divided by, it is sine C in a triangle BAC equal to A. That's right. But in a, suppose this is stopped. But in a triangle ABC, A divided by sine A equal to B divided by sine B equal to C divided by sine C. This is equal to twice R. Therefore, From star you will get P divided by, for sin A you may write A divided by twice R equal to Q by B by twice R equal to R divided by sin C means C divided by twice R, like this. This means that P by A equal to Q by B equal to R by C. P by A equal to Q by B equal to R by C. What is A? This is B. AC equal to B. The opposite side of the angle C is small c. AB equal to small c, and it is small a. Opposite side of the angle A is small a. BC means small a. This means that P by BC equal to Q by CA equal to R by AB. The forces are proportional to the sides of the triangle. That is the forces. That is the forces. Our final conclusion is that is the forces are proportional to the sides of the triangle ABC. That is, the forces are proportional to the sides of the triangle ABC. We have solved 3 problems today. Dear students, I want to stop here. We shall meet tomorrow again. Thanks for attending the class. Thank you very much.